Hello everyone. It's my great honor to present our work Video2Robo, accepted by CVPR 2026. As we all know, imitation learning is a key approach for robots to quickly acquire manipulation skills. However, it relies heavily on high-quality and diverse embodied data, which usually requires huge time and human labor. Therefore, data generation has become a major research focus to alleviate this problem. Unfortunately, existing data generation methods either require physical robots, teleoperation devices, or depend on physics simulators. They are still costly, cumbersome, and difficult to scale. Thus, we ask, is it possible to generate diverse, high-quality robot data without relying on costly hardware or intensive manual effort? To answer this question, we propose Video2Robo. It takes only one monocular human demonstration video as input. Through 3D GS-based diverse and efficient data generation, it enables seamless sim-to-real transfer to both simulated and real-world robots. This is the full pipeline of Video2Robo, which contains 3 core modules. First, scene and skill parsing. We extract 6D object trajectories and decompose manipulation skills from the input video. We first perform cross-frame instance segmentation and tracking to obtain consistent object masks using Entitive 2 and Co-Tracker 3. Then we generate 3D GS models via Trellis and conduct our 3D GS-based 6D pose estimation with RGB, depth, mask, and tracking losses to ensure temporal consistency. Finally, based on relative object motions, we decompose tasks into grasp skills and task skills such as pouring, placing, stacking, and sweeping, yielding reusable motion priors. Second, scalable data generation. We automatically generate large-scale and diverse robot demonstrations based on 3D GS. We first perform object pose rearrangement by randomly placing objects within safe regions. The designed robot object coupled motion ensures physically plausible execution throughout robot transit, grasping, transfer, and task execution. We also apply comprehensive augmentations. Object pose, texture, background, lighting, and camera view are fully randomized, with per-frame augmentation to maximize data diversity. 3D GS enables fast and photorealistic rendering without artifacts like penetration or slipping in traditional simulators. Third, we evaluate our method on 6 distinct manipulation tasks. The generated data is used to train a diffusion policy model. We build a simulated benchmark based on RoboSuit and construct a similar real-world setup to validate the cross-domain generalization of the trained visual motor policies. Next are the experimental results. For monocular 6D object pose estimation, compared with Megapose and Foundation Pozo, Video2Robo achieves significantly better average recall and temporal consistency, especially for both symmetric and asymmetric objects, laying a solid foundation for downstream data generation. In terms of data generation performance, compared with MimicGen and SkillGen, Video2Robo achieves 100% success rate across all 6 tasks and is the fastest. Policy evaluation is conducted in both simulation and real-world settings. In simulation, our method substantially outperforms all baselines under environments with multi-dimensional variations, even though baselines benefit from in-domain training, while ours comes from a 3D GS to simulator cross-domain setting. In real-world robot experiments, our policies demonstrate strong sim-to-real transfer capability and are robust to variations in lighting, texture, background, and camera view. Furthermore, our method can directly learn from internet videos. Here we show results from a video taken from another project's website. Our framework can be naturally adapted to multi-skill tasks. For example, here we show data generation for a task involving both placing and pouring. Here we show more results on additional tasks. In addition, synthetic data from Video2Robo can provide privileged information to enhance policy learning, such as object bounding boxes and gripper positions. Thank you for watching. Welcome to visit our project page for more visual results.